All right, so if you just, have your calculator ready and just watch, you don't really need to write anything down today. So we're gonna do exponential functions today, okay? So, and we're gonna have some word problems that are gonna be growth and decay situations. All right, and there's a formula that you'll get that works for like all but the first word problem you got on your homework. The first word problem on homework is like a little different than the example. Anyway, we're going to talk about exponential functions. You guys already know what a base is. We're going to introduce what an asymptote is, and then we'll have growth and decay problems. All right, so the example they use is talking about computers and their processing power. And transistors per integrated circuit, when they started, you got 60 back in 1965, and then in 1 year they had 120 transistors for an integrated circuit, and then 67 it was 240. It kept doubling each year. Okay, so that's an example of an exponential growth problem. Growth that doubles every year can be modeled by using a function with a variable as an exponent. So that's what an exponential function is. The variable, the x, is where the exponent goes. The b that they have up here just represents the base. It's going to be some number. In this example, that base is 2. Okay? But it could be any number. All right? But b has to be positive. So it's going to be a positive base. And it won't be 1. Because 1 to any power is what? 1, right? So you never have 1 as the base. But it will be a positive base, what we're doing right now for these exponential functions. Okay, and again, your exponent's going to be the variable x. Okay, and some examples it'll be a different letter, but when you put it in your calculator, you're going to use that x letter that you've been using. Okay, so the graph of the parent function of f of x equals 2 to the x is shown. So this is 2 to the x. All growth graphs for exponentials start out kind of flat and then they take off like that. Decay ones, they get small really quick and then it kind of flattens out. They just look more like an L here. But they look basically the same. Okay? The domain, what's domain mean? The x values, remember? Domain represents x values. X values are all real numbers. We could go from 0 to positive infinity or from 0 to negative infinity. Any number we can use for x, for the exponent. Okay? So when I go 2 to the negative 2 power, my answer is 1/4. And 2 to the negative 1 power is 1/2. And anything to the 0 power is what? 1, right? You guys knew that. 2 to the first is 2. 2 to the second is 4. 2 cubed is 8. 2 to the fourth would be what? Double 8. 16, right? If I go this way, what's 2 to the negative 3rd power? If this was 1/4, 2 to the negative 3rd would be 1/8. Yeah. Okay? So what's happening is they have this dashed green line here. This red line, it gets closer and closer to that dashed green line, which is the x-axis. Okay? And this dashed green line, the x-axis in this example is called the asymptote. An asymptote is a line that a graph function approaches as the value of x gets very large or very small, but it never actually touches it. Right? If I have 2 to a power, no matter what I put in for the exponent, I'll never get 0. It'll get really, really close to 0 if I go towards negative infinity, but it will never actually equal 0. Okay, so that's what an asymptote is. It's like a boundary. And we won't, for a while, that's all you'll see about asymptotes. It's just that just that definition, this introduction to it. Okay, we'll talk about it later on as we get further on in the year. Okay, so a function of the form a times b to the x power, again, a being a positive number, and b being greater than 1, that's a growth function. So the base has to be bigger than 1 for it to be a growth function, the base of our exponent x. If our base is between 0 and 1, like 1/2 or 2/3 or 0.2, then it's a decay function, that base, that b value. All right. Also remember, anything to a negative exponent, we can move it to it's in the numerator now, we can move the x to the denominator and make it a positive exponent. If I had 1 over x to the -2, to make it a positive, I'd make it x to the second over 1. Okay, that's something we learned really early in this class. Just don't forget about that. It's like doing the reciprocal. Okay, so is this growth or decay? What's my base? Base is not 10. 3/4 is the base, right? Whatever is being raised to the x power is the base. So, is that bigger than 1, 3/4? No, so it's not growth, it is decay. Okay? It says graph it. Just put it in your y equals. Hit your y equals button. Put 10 parentheses 3/4 to the x. And 3/4 is just 3 divided by 4, right? It's just a division problem. That's what a fraction is, a division problem. Right, caret x. Remember your caret button.
Oh my. I know what I'm doing.
Okay? So this is a decay problem again because my base is less than 1. My base is between 0 and 1. Okay, my graph looks like that. How do I get these values on your calculator?
You go to the graph.
How do I go to the table? Second graph, right? So second graph would get you a table of values. Okay? What's the asymptote for this? What's it getting close to but actually never touching? The x-axis again, all right? We'll never get 0.
Wait, you round up? Why would you just put like the actual thing?
What are you talking about? What are you rounding up?
I have 3.1641. Are you rounding up?
4.
Yeah.
Yeah, it must have rounded up to tenths. There we go.
My calculator going to like odd numbers.
On your table? Okay, go second window. Window's right there. You get table set. Just put 0 there. Hit enter, and then this one put 1. It's probably at 2, isn't it?
4.
At 4? Okay. We'll put 1, then go back, second graph. It should be all 1s then.
Okay, thank you.
Great. What? Yes. Yes. There you go.
Table start, so you can give 1 for the.
Your table start can say whatever, but you want, table start tells you where your table will start when you look at it. And this little triangle, means your change, what increment you're gonna go by. So if you put 1, it goes by 1. So if you wanna put 1/2, it'll go by halves.
How do you get that?
Second window. Window's right next to the y equals. It says TBL SET, that's for table set. So you can set your table to go by any increments you want and start anywhere you want. Okay, but usually we just go by ones. But if you wanted to go by tenths, you could. All right. Any other calculator issues? Okay, so decay graphs always look very similar to that. They come down real fast and they kind of flatten out. Okay? What's this one? Growth or decay?
Growth,
Why?
because it's higher than one,
What's higher than one?
the base.
Right. This is the base, right? That's the base. Whatever's being raised to the power, we call the base. Okay? So that's a growth one because, like Hunter said, that's bigger than 1. Whenever that number is bigger than 1, it's growth. When it's between 0 and 1, it's decay. Easy to remember, right? Okay, now, this one, when I put it in my calculator, and I graph it, I can't see it. Okay? If I put 0 in for x, what's 1.05 to the 0 power? 1. What's 100 times 1? 100. This only goes up to C, 0, 10, right? So here's what you can do to see it. There's a different zoom button, all right? You listening, Nate? Hit zoom 0. You can go down, but you can just hit the number 0, but that means fit. Oops. Zoom fit. So it fits on it that you can see it. So it'll look different,
Oh, wow.
but you'll be able to see it. Okay? So go zoom 6 if you want to go back to the basic window that you're used to seeing. If you can't see it, hit zoom 0 and it'll show you some of the graph.
Zoom. 0.
Okay? Any questions? We doing okay? All right, let's look at another one. Growth or decay?
Growth.
We all understand why it's growth.
Yes.
Again, because my base is bigger than 1. Okay? Again, if I put it in the calculator, it's gonna be going out left to right. So clear it out. 5, parenthesis, 1.2 to the x. All right. Now, when I hit graph now, it's probably going to be at what I just had it, the zoom 0 one. So I'm going to hit zoom 6 to go back to the normal. I think I'll be able to see it. Yeah, there it is. So I hit zoom 6 to get that look. Okay? So if you have to graph something, the calculator's going to do it for you. You guys okay with that?
Yep.
They all look pretty much the same, the graph. All right, we're good so far? Okay. If we have a growth or decay word problem, this is a formula we're going to use. Okay? It says you can model growth or decay by a constant % increase or decrease with this following formula. So this A is the final amount. So whatever it grows to or shrinks to equals the initial amount, whatever it starts at, times the quantity, 1 plus the % increase or decrease. If it's plus if it's growth, it's minus if it's decay. If it's an increase, 1 plus R, the rate, decrease, 1 minus R, to the T power. Now, when you try to put this in your calculator, you're going to use X still, okay? T represents the number of time periods. Usually it's years. How many years will something grow to be a certain amount? Or how many years will something shrink or decay to be a certain amount? Okay? Okay, now the first word problem you have is about a softball bouncing. They try to drop it, and it says how much it bounces. Okay? You won't have 1 plus or anything. Whatever they say it goes, that's the number you'll put in here for that one. Okay? I think it's 2/5. It bounces 2/5 as high. So if you drop it up here, it'll bounce up 2/5 as high as where you start. So you'll just put that fraction in here. Okay, so is this growth or decay?
Growth.
Growth. When we're doing an investment, we're trying to grow money, right? So what's the little a?
5,000.
The 5,000. What's my R?
6.25.
Okay, now, when we put in the 6.25, we don't actually put it in at 6.25. 0.06. Yes, move that decimal point to the left when you plug it in for R. So your percent, you're going to move the decimal point 2 spots to the left. Okay?
Wait, why 2?
Percent means out of 100. So you have to go over 100 spots, you know. So that's how you're going to put it in your calculator. Right, to do the graph. Again, you don't have a T on your calculator, you're going to use the X, okay? Go ahead and put that in your calculator. 5,000, 1 plus 0.0625, caret X.
I guess very nice. I just don't see
Okay, why don't I see it?
because it's out of the range.
What's it starting out at? 5,000, right? So you have to hit what? So you can see it. Zoom 0. Very good. You guys are so smart. Okay, so it's still something happened there. It's starting to freeze up. What are we looking for?
When it's going to be worth 10,000.
All right, so where can I look to see where that 10,000 would show up?
Second graph.
Yeah, then the table. So go second graph and scroll and looking on the Y column where you see 10,000. Between 11 and 12, right?
Yep.
The first time you see 10,000 is at 12, right? Okay, I don't know what happened to my calculator. I didn't hit enter.
When you hit enter, it pops
Oh, okay, thanks. All right, so here's something else you could do. You could go to your table. Anybody having issues that find it on the table? You know, if you go down, looking for the 10, 97 at $9,700, 11 years after 10, or 12 years is $10,349. If we want to get a little more accurate, we understand it's between 11 and 12 years. If we want to get a little more accurate, you can hit, and it tells you here on the slide, you can hit what button?
Trace.
Just trace, okay? So if I go and just hit trace, it starts at the y-intercept and just hit your right arrow key and watch the y values get bigger until you get to what number? 10,000. All right, so just hold it down. If I hold it down, it kind of gets crazy, so I hit.
11.489 something.
Yeah, if we wanted to be more accurate, we'd probably put 11 and a half, right? 11.5.
Yeah, 11.5.
Okay? But that's what we do to, answer those questions. We're going to use that formula and put in our calculator and then trace, okay? Autumn?
Is it supposed to be exactly at 10,000? Mine's not.
No, it won't be exact. It'll be a little bit off. Any other questions? All good questions? Okay, here's the table they looked at. All right, how about, this is another what? Growth, right? What goes in for little a?
350.
350. What goes in for R?
14. Well, 0.014.
0.14, right? How about this one? Which way are we gonna go this time?
Down.
Down, right? So this one, it's 1 minus R. Okay, what goes in for A?
5.
All right, and what goes in for R?
0.03.
0.03. Okay, you figure out when it's gonna drop to 8,000. So go ahead and do that one. Do that decay one. And figure out how many years.
Yeah.
21.9148. Listen, take it down. Silly goose.
I got 21.9 is what I got. I got that. When I,
21.7. 21.9.
at 21.7, I got $8,002, or 8,002, what is it?
It dropped below though.
Oh.
Right, so it said below, so I went one more push and got 7,951. Right now, if you go to the table, you just go down until, so like 22, right? Ava?
I was just doing trees, but then it passed.
You just, usually you get to the edge and then it kind of resets and then you hit it some more and it should keep going for you. Hit the right arrow key. Just hit trace. You don't have to hit zoom trace. Yeah, zoom 0 gets you to look at it, right? And then trace lets you follow it.
Yep.
Okay, any other issues?
This is easy.
Okay. Oh, you're trying to- Okay, we got this?
Yeah.
This makes sense?
Yeah.
Pretty easy day, right? That's basically it.
Oh my God.
Oh, there is homework. And I bet you can get it done before you leave.
Yeah.